Okay, let's say good afternoon to everyone. This will be the second or third webinar of SONarchitect. In the very first one, I collect some doubts regarding geometries, junctions, materials, and now I'm just giving some pre and brief uh, notes, brief webinars just for answering those doubts. The first one was just to show you how SONarchitect is dealing with the arbitrary geometries. Just forget about one square box versus another square box. Just draw your building plan by plan so you can create your own building, your real building. And that's the philosophy of SONarchitect, just dealing with the entire building. But anyway, SONarchitect just calculate the acoustic insulation in buildings according to the norm, European norm 12354. So this norm has very weak limitations regarding tiny enclosures or the small dimensions. That's why here in the project configuration tab we have included some checkboxes where you can exclude of the results the flanking elements that are minor than 13 square meters, or the impact sound insulation from slabs that are below this surface. Why? Because for tiny elements, the SIA, actually the method that is below the 12354 norm, does not work properly, and it can fake the results. So that's why I always say that okay, we can do a real building, but you have to think about it acoustically. So you have to create an acoustic model of the building. So try to think smart, try to create this this building smartly, not just thinking about vertically but or horizontally. So you will avoid some small flanks in the walls and also some small flanks in the slabs. So you will be able to rely on those results. Okay. So you will be able to rely on those results if you just plan or think about the totality of your building. Let's create a new one, a new project. As I mentioned, as I showed you in the very first webinar, you can easily create your building just at a raised hand method, where you just draw or using those tools of perpendicular and parallels, or just giving or telling SONarchitect the dimensions of the line, a line of 5 meters at 45 degrees. So you have it here. Just show all the dimensions, and then just edit it in the 3D view. Okay, so just go back to the and create not just this one but more than this. In case you have more repetitions of this one, you have this, and you can then check if you are doing things okay. And one of the first hints for creating an acoustic model of the building smartly is just managing the plans. So if you want to really avoid those micro planks or those very tiny slabs, just copy plans, so you can get approach or take the lines of the plans below, so you are sure that you're drawing a continuous plan, a continuous wall, also vertically. Okay, I don't know if I explain this clearly, but for example, if here we have these three enclosures, and in the plan above it just have one, but we share all the facade. So just copy this, okay? Not create another one and just draw over it, but copy it, edit that this will be only one repetition, and then with the selection tool just erase the interior walls. And now you have this. The four first floors are divided and the attic is empty. But this wall is continuous. There won't be any micro flanking here. So you know that you are drawing smartly, okay? But most of the times you're not dealing with a raised hand model where you draw just lines. So most of the times you got the tracing plans for the from the architect, and you import them. Now I'm going to show you a very tricky building where you have to use this smart thinking, horizontal, vertical smart thinking, and also the visualization tool. And this will be, okay, I'll create another one. I will save it. Okay, just let's import the drawing, the DXF drawing that I imported in the very first webinar. Just choose those layers they want to import, the units, the scale of the DXF, and just press OK. And this is the building. This is actually tricky because this small building here was an old one, and this is a brand new area that will be built in this case. So this is the first floor. So these two buildings share this first floor, and just what you have to do is just sketch somehow this building over the lines. Okay, just simplifying as much as you can. You don't have to do the facade first, but this way you have clear and you have defined your drawing area. So it's easier for you then to zoom and to zoom in, zoom out, and pan. Okay, but and one advice is just clear or clean the VXF before you import it. so you can easily you can more easily draw these lines. So the lines are just the mid lines of every wall. But as you can see, I don't care too much on centimeters. I'm thinking about meters. That's why sometimes I just switch, or I just rotate or switch from the shift from the original line. But what we really have to do is think smartly and take some lines from other enclosures. For example, here, in spite of you have to erase some other ones, but please just share some lines so you can get the best of SONarchitect for dealing with it. For example, this is only one floor, and these will be 2 floors. But the thing is that, well, let's draw a little bit here, because this will be more interesting than the other one. As you can see, it's just a sketching, no matter the centimeters of the walls, because we are always in acoustic, we are always talking about logarithms, so centimeters we don't care about it. Okay, I think this is enough. I don't want to bore you. Okay, so this is the first floor, but the second, but in this building over here, the northern one, just have 1 floor, but 1 floor at 3 meters height. And this is the older building and has 2 floors. 2 floors at 1.5 or 2.5 meters high. So we are having in the same model 2 buildings with different heights. So how can we deal with it? I mean, for giving you a better idea of what I'm telling, is that the model is something like this. This is supposed to be the old building of 3 meters high, and the new building of 3 meters high, and this is the old one, the southern one, of 2 floors of 2.5 meters. So what we have to do first is think about how many plans do we need for doing this, for creating this model. There are actually only 2 plans, 2 real plans, but for modeling in SONarchitect we need more than 2. Why? Because we have to define some heights, and then we can erase the slab, the intermediate slabs, just for creating the real model. Okay? Do you follow me? Since we are very few, I'd like to have some feedback from you. We are 23 right now. Okay. So you can see this is the first floor. and this is the common one, okay? And it will be since this part, this part is 3 meters high and this part is 2.5 meters high, the first plan will be just 2.5 meters high, okay? And then I reply this plan, and so is the intermediate and just guess how will be the height of this plan, since in the very first one we have 2.5 and this is 3 meters high. So just create a plan of 0.5 meters height and press OK. So now you have this. Okay? What we have to do now is just modify this part, or just erase or hide the VXF of the first plan, just clicking on these little eyes here. Let's try it a little bit. Okay, and I can import now the second floor, and you can see here that there is no divisions. There are no divisions here in this northern building, but there are some divisions here in the southern one. That's where we have to think smartly. Why? Because we had some. Let's close first this one. Okay. And we had some divisions, but now we have some different ones. But the most divisions we got from the plans below, the better. So we have perfect match between plans. And this is better than have just small slabs that will be tiny planks that will fake the values, okay? So this is small drawing. So for example, here just erase these ones, these, and create this new one here. Just close this. This will be the elevator, so it's I also want to show it to you. And for example, let's go to the plan below and just create the elevator also here. Okay. So now in the 3D model, now this 3D model, now the calculation one, we have these. We have an intermediate plan of 2.5 meters. So now we can just erase all of these. So you have this model that is here a building of 3 meters high, and then here a building of 2.5 plus another plan of 0.5 that we will erase later. Okay? But now we have to create the third one. So let's replicate, let's copy this one. This will be the second floor. And this will be 2 meters high, since we have the very first one we had in 2.5, the second at 0.5, so now there is only 2 meters left. Okay, but 2 meters left with no northern building, so just erase it. Okay, and now we have it here. So we just need to erase those slabs of the intermediate plan. Okay? And you have it all. So we have in the same model 2 buildings, one at 3 meter height and another one of 2 plans of 2.5 meters. That is something like this. And then we also have to erase the slab of the elevator, because since SONarchitect you can also create elevator shafts. And that's all. This is the 3D model of the building. Just assign some materials here. Slab, roof, facade. If you press F, you just select all the facades. If you press I, just select all the interior walls. I for the interior walls, facade, all the facades. Now, in order to avoid some user mistakes, we have a checker where SONarchitect watch if you have selected or if you have assigned all the materials. Otherwise, a warning arises. Then assign some users. Let's protect it, all of them. I don't care, just for showing you. Okay, and this is, as you can see, this, this is the 3D model of the building, where 2 floors. SONarchitect knows now that there are only 2 floors, in spite of we have drawn more than one. And then you can inspect all the rooms. With all the adjacent rooms. And all the parameters, urban and impact noise, that we have defined on the requirements stage. But the two ideas that I'd like to show you in this brief webinar were those. The thing that you can draw anything that you want. Just think of modeling, telling, and managing the plans and the virtualization tool. And the other one is that let's think a little about it and create an acoustic model of the building. Since just trying to avoid those microplanks that might appear during the drawing, taking the more walls or the more lines that you can from the other plans, so you have a perfect match between plans now. Okay, so this only was for drawing and for checking how powerful is SONarchitect with arbitrary geometries. Anything that you want, you can draw anything that you want. And I'd like to know if you have some doubts regarding drawing. And we are planning to do another not that brief webinar, but a very specific one about junctions next week. I'm just mailing you with the time and day, how it will be suitable for you, and it will be indeed very interesting. So we have plenty of time. If you have any doubt, yeah, Panos, the doors you can assign. Of course, I just assign slab, roof, walls, and facades because it's the only thing that I need. But I can also assign doors here. For example, in this wall, I can assign this wooden door. Just telling SONarchitect which is the area of this door, and you have it here. And it will calculate the 1, 2, 3, 5, 4, the urban noise insulation between these two rooms, taking on account this door. This is not SONarchitect is not a design tool, it's an acoustic tool, so that's why the door only is displayed like this. Okay, all like this. You have it here. Any other doubt? I don't know if this was that interesting for you, but I think that these tricky things are not trivial. That's why I like to show it in a very, I think that it's very visual example. Not that common, but at least very visual, and you can have a better idea of how to deal with with plans and virtualization too. And it doesn't have to be from this webinar. You can just expose your doubts right now. You have the time. You have a chance now. Any other doubt about SONarchitect? We have a doubt of open terraces. What do you want to know, Jean-Philippe? Of course, you can erase the slabs you want, and you can also create patios over here. And these will be considered also, these walls will be also considered facades. The balconies, okay, the balconies, it depends on what you want to do with balconies. But if you just want to approach the insulation, the improvement of the insulation that this balcony is giving to the facade, just go to the facade section here, select the facade, and just assign a facade shape factor according to the shape of the facade. And so you can assign here a balcony and tell, okay, this balcony is this height, and the absorption of the ceiling is this one, so it will have better insulation regarding this shape of 1 dB. Okay, I have another doubt of panels removed from Cyprus. What do you mean with this connection tunnel between 2.5 and 3 change? You mean this arm that we have here? And what do you want to know about it? It's just there is a physical connection between them. Okay, you can here you can insert here a door, for example, here. There can be a physical connection, but this is only a geometrical model. Was that your doubt? Okay, Andreas is asking, Andreas is asking, when you have a part that is not living up to requirements, how you can easily find the problem? That's cool. I calculate, okay, and I have some problem here. Just from this, not this room, but this, as you can see, this is the elevator shaft. And we have this airborne noise, 2 walls. This is something that is not common in the software that deals only with 2 boxes. We have here 2 rooms that has in common 2 walls. And this is not trivial, also for checking it. But let's check this, and you have it here, this separator, this wall between these 2 rooms for the calculation of airborne noise insulation. And there are 11 paths implied in this calculation. This transmission path, the direct one, and all the planking paths. It's not easy to see in a 2D model, so way that we have it here. And you can see that SONarchitect highlights in red the guilty, I mean the weakest one. Sometimes if there are some weak paths, they are highlighted, they are displayed in orange. But if you see a path in red, it is said that you must change, you must improve or put a better insulation solution over there. Otherwise, it won't fulfill the requirement. And double click and you can see which is this is the direct one, and you can see that this is a gypsum molding board, and you can see that this is the guilty. So just press G and you go to it is said that you press G, but somehow it doesn't work now. It must be because of the web. But it highlights the guilty here. Let's open another one. Let's check this one. Close. Okay. I come at this. For example, this part. Just press G, okay, press G, and you have this selected enclosure highlighted here. Just put, in this case it was, you can see that it is very easy to go back to 2D and calculate again. Okay, yeah, just press G and it goes directly, the key in the keyboard, it goes directly to the enclosure that you have to improve. Yeah, David is asking how to change the calculation for a cube radius on a wall. Yes, 1, 2, 3, 5, 4 doesn't deal with curved surfaces, so you have to somehow approximate it with some segments. But the less segments, the better. Actually, that's because of this webinar is dealing with. That if you put some, I can load the other one. Okay. Let's go to the first floor. You need to create, yes, for example here, this could be a curved wall, but I'm just telling you that the less segments that you are drawing, the better. Actually, it would be better if you do just like this. The approximation will be better for not for the reality, but for the 1, 2, 3, 5, 4 norm. The segments will be bigger, so it will the behavior will be more suitable for the norm. Impact noise from balconies. Okay, you just have to create, Richard, you just have to create some tiny enclosure that could be the balcony and calculate it, but then you have to erase it since it depends on how important is for you those balconies and how big are they. What's the example of those balconies that you have, Richard? Let's start with these other, they could be an outside corridor. Yeah, but that is more like a gallery instead of a balcony. Because you have to assign, it's not that easy because you have to assign a facade for those balconies. And for impact sound, it doesn't take into account those facades, since it only takes on account the planks in the receiver room, so the planks in the room below. I don't know if I'm answering you, Richard. The thing is that we don't calculate, SONarchitect doesn't calculate sound, impact sound insulation for non-closed enclosures, for open enclosures. Jean-Philippe is asking about the open terrace. In case of a terrace with 1 meter located on ground floor, can we consider it as a first floor room of 1 meter height without roof? I cannot, I don't know if I'm understanding you. Or maybe you can just, Jean-Philippe, maybe you can mail me, or we can have some Skype so you can show me what you're talking about. So any other doubt? Okay, for outdoor propagation, outdoor noise map, you just have to assign a noisy enclosure, and a noisy enclosure is created here on the requirements, where you can create a room type, and within this new room type, just create a new requirement. In the requirement type, you can put error, impact, reverberation time, or indoor sound pressure level. Just assign here night with white noise, pink noise, or brown noise. And this is the noise pressure level inside, indoor, just 100. And this will be a room type that will be a room that will be a noise source for the outdoor noise, and also for the incoming noise in the adjacent rooms. Actually, I erase this because we also have this noise enclosure here. and I can go here and just assign this as a noise enclosure. Go to materials here. And now, because of this, you have the noise map of this enclosure. Okay? And of course, you can also, as I told you, you can also have, and not only have the outdoor, but also have the, if I add here a new requirement, ergo sound insulation, I can put that this will be the noise pressure level that we extract from a noise enclosure that could be adjacent. Otherwise, if you don't have any enclosure, any defined enclosure, and you define a requirement of this, of a level, of an incoming level noise, a warning is arising telling you, okay, you haven't defined any noise enclosure. Jean-Philippe, this was this is an approximation of the Annex D of the 12354 part 4 of the norm. So it's just if we put here there is no interference between buildings, it's just an approximation of the outdoor noise. We just make a summarizing of all the contributions of the different rooms and facades. The next was Dave Powell. What is the resolution of that contour map? Please, is very good. It looks like maybe 2 centimeters. I actually don't know what is the resolution of this. But this is only, okay, this is only that approximation extract from the annex. But the useful data is here. The equivalent acoustic power on 1/3 octave bands of that facade. And this is for example, the value that we have to enter in a noise mapping software just for having a better sound propagation bubble. This is only the annex of the norm. Looks good, but it's only this. No, sure. That's what I meant, Jean-Philippe. This is not for ray tracing software. This is only for an approximation of the sound propagation. No. This is only an approximation of sound propagation that is within the annex of the 12354 part 4. Okay. So you can use it. For entering, you can have an idea of which is the noise outdoor, but you won't have an idea of what's the noise map of the area. But what you do know is the noise power that comes from this surface. That is 58 dBA. Okay, that's the main thing. Katarina from Poland is asking if we change the materials of the existing windows in our model. Sure, you can change anything that you want. The material catalog is totally customizable, so you can change all the windows. And for example, if I put some windows over here and here, you have the material list. Just select the window, and if you want to change the entire all the windows in the building, just select another window here and just tell OK, replace. On all the solutions for the windows will be replaced. This is very useful, very tricky. Mario is asking, we can have BB93 finish. You have it. BB93 assessment is done in SONarchitect right now. Actually, we have it. Oh, we have here the requirements. I can load. These are actually the limits of the BB93. Is the building bulletin document regarding acoustic design of schools for the UK. Next one. I have a client with a greenhouse or conservatory filled with plants, and I want to change the humidity in room. Okay. Sure, you can change the humidity here in the program configuration, program settings. There are some specific conditions about the ISO 9613 temperature, or you can create you can have some predefined one. So these will modify the calculation of the reverberation time. Does it answer to your question, Dave? Katarina, if you don't have that icon in your version, you should update it. Andreas, regarding the windows, we know that some windows are no matter the crystal, but the profile. But as soon as you enter the sound reduction index of that solution, I mean this is a thing of the manufacturer. Okay, Katerina, just show me send me an email. We can see that. Okay. Yeah, Andreas, it's very tough. But you have to just take the data sheet of your manufacturer of those kind of windows. Dave, no, that's not possible to make difference between two between two humidities within the same model, but you can do it twice. That's my advice. Since it's not a big deal to calculate, go back and calculate again. Just do it twice, please. Actually, it's a very specific case. What do you mean? Yeah, I can, Gabriel. I will just mail me, and I'll answer you with the BB93 file. Dear Panos, I'm telling you that the noise mapping is only an approximation of the annex of the norm. We don't do ray tracing, no diffraction, no reflection, anything. Just some approximation of the propagation of this noise that comes from the walls, from the facades. Okay? Okay, Jean-Philippe. I can open this for having a better idea of statistics. I can open. I will calculate this huge building that I always use the same one. And I go to statistics. And here you can see the histogram, the interactive histogram of this project. And for example, I can select the protected rooms, and the requirements are say that I calculate the sound insulation parameters of these protected rooms against a different unit of any other type of room. And there are those numbers. So there are 2,411 calculations that are okay. These calculations are between a protected room and any other type of room in a different unit. And it compares it with the requirement. And there is a minimum of 26 dB and a maximum of 99 dB. That is kind of weird. And then you have it all here, all these calculations. For example, if I select this 174 column, is that there is 174 calculations between rooms, which result is 70 dB of the DNT. So there is yes, 174 calculations, not rooms, but calculations. So a lot of protected rooms versus any other type of room in a different unit. So are separated 174 times 70 dB. So you can take the worst cases here, but you can see that some of them are the same enclosure, but you know that every enclosure has more than one adjacent room. So it has more than one calculation of sound insulation. Yeah, thank you all of you for your attendance. Yeah, we are planning to do the other one, but just feel free to contact me whenever you want. I can answer you by mail, or we can arrange a meeting like this or via Skype.
Yeah,
Yeah,
just the
just the
last
last
chance
chance
for
for
one
one
more
more
doubt,
doubt,
and we
and
are
we are
leaving.
leaving.
Thank
Thank
you,
you,
thank you
thank you
all
all
of
of
you
you
for
for
your
your
attendance.
attendance.